Hey guys, this is Abhishek, and in this video I will show you two different ways by which you can evaluate your model. And the two different ways are, first of all, which are also assumptions, that your errors should be normally distributed when you plot it against the predicted values. And so that's like normality of error. And then there is an independence of error. That means your error should be independent against their order. So whenever you plot your errors based on their order of observation, then it should be normally or independent. So how you can do that is, first of all, the first one, the normality of error, we can plot it with the help of scatter plot. So what we have is ELT.scatter, and the first one is y underscore pred, which is basically your predicted values on the x-axis, because what you are doing is plotting the errors, and errors are nothing but observed minus predicted values. So what we can do is we can create residuals, which is also called as errors, by reducing the or by subtracting the predicted from the observed values. So what we have is basically y underscore test minus y underscore pred, and this residual I will just convert it into series so that I can plot it properly over here and res it. If I go ahead and execute it, okay. So here is our residuals. This is the axis for residuals, and this is the axis. This is the x-axis for my predicted values. And what we are seeing, that there seems to be no pattern or any linear combination or a cyclical pattern appearing from this chart. And another thing is, to better see it, what you can do is you can actually produce the H line starting from 0, going from, let's say, 5 to 40. If I do that, a line is being produced here on the center where the residual value is 0, and you can see that the values are evenly spread or normally spread across these lines. So this is called normality of error. If any pattern is appearing, then you further look into the model and try to transform it, or by either removing the variable or doing some transformations like log transformation and all. The next one is the independence of errors. So we have created the residual. So what I'll do is I will just plot the residual values against its order. So what I have again is plt.scatter, and in case of the x-axis is basically the order of values, so that's basically your index. So resit.index, and on y-axis we should have values, so resit.values. Okay, and here I have the plot for independence of errors. So this is basically your order of observations that we are getting from index, and this is basically the value of your residuals. And again, if you want, you can create the H line, the horizontal line, to see whether there is any pattern or anything. So what do you want to start with? 0, going from 0. So starting from 0, that means starting here, dash line, and it should be from 0. This is the second 0 over here, and going up till the 140. So maybe, let's say 150, because values are coming up till here. So here we are, starting from 0. This is the 0, again 0 this. And as you can see, from here, this chart, again, no apparent pattern. That means our model is doing fine. There seems to be no pattern from either from the normality of error or from the independence of errors. And there is another straightforward method which is called Durbin-Watson statistics, and that you can import from the stat models package. So stat models.stat tools, import Durbin underscore Watson. So what this statistics is basically saying is that based on a particular value that you are getting as an output, it shows whether there is a serial negative correlation or a serial positive correlation between of these residual values. If you get the value 0, that means there is a negative serial correlation. If you get a value as 4, it means there is a positive serial correlation. And if you get a 2, then it means there is no issue. So let's go ahead and quickly see it. Durbin underscore Watson. And what it needs is just the residuals. So we already have resit. And if you see, the output is 1.75, which is very near to 2. That means there is no serial correlation which is present here, indicating the independence of error. So that's the method to check the independence of errors, and it basically sees that whether there is a positive or a negative serial correlation between the order of values and the actual values. So that's about it, but there are other methods also. There are a lot of different tests which can be done based on what you really find it from the model output, and then plotting these observations. You can further deep down. There is something called as homoscedasticity or heteroscedasticity, and a couple of other advanced tests or checking the assumptions which you can do. But I'm leaving up with this as it is more and more deep dive, and we both need to really understand that subject and go deep down there. So that's mainly I wanted to show you these model evaluation techniques based on the residuals, and I'll meet you in the next video, the new topic.